I can imagine my life after 40 years. Got up early in the morning with bit of lung congestion. Got my body scanned and report says deteriorated condition of my lung. I went to my lab, got my lung printed and surgically replaced. Sounds like science fiction for you, but trust me, the technology called as additive manufacturing, the way it's going, it is possible in near future. Additive manufacturing, or more popularly known as 3D printing, it's not a new terminology. In fact, we heard it as early as in 60s in the science fiction work of Arthur C. Clarke. And since then, in lot many Hollywood science fiction, we have seen a glimpse of it. In fact, this science fiction have predicted the printing of human body part. In present scenario, we have incorporated 3D printing in our day-to-day life in some or other form. 3D printing has changed the working pattern of various industries, starting from rocket science to a Michelin star kitchen. 3D printing is not just a trend, but in fact it has revolutionized the complete concept of manufacturing. Manufacturer and enthusiasts have started printing the models starting from very small to a large aspect, whether it is made up of metal, some manufacturing tool, or some human body part, and in fact in the field of dentistry too. What makes this technology more appealing is it gives the ability to manufacture, to rapidly prototype and manufacture component and parts. Even the complex structure which we are not able to produce or manufacture with conventional technology, we are able to do with this particular technology. This technology helps to save the time and also act as a cost cutting. With the help of this technology, we are able to produce a wide variety of material starting from plastic, metal, fiber, in fact human body part which we never thought of. So what exactly is this 3D printing? 3D printing is manufacturing any material layer by layer. Basically, it's like printing a multiple layer of two-dimensional object, making it into 3-dimension. When we talk about 3D printing includes both subtractive and additive technology. This additive technology or additive manufacturing technology is nowadays popularly called as 3D printing. So what is the difference between this additive manufacturing or subtractive manufacturing? Additive manufacturing, we add layer by layer, whereas subtractive technology, a piece or block of any particular material is taken and it is milled or reduced to get a desired shape. The advantage and disadvantage. When we talk about subtractive technique or subtractive milling, this technique involves reduction of material from a block, where lot of material gets wasted, whereas in additive technology this becomes an advantage where we save a lot of material. In fact, the subtractive technology has a disadvantage that few geometries cannot be printed with the help of subtractive technology. And you just imagine if you want to print a complex structure, imagine you want to print a model of kidney or a model of brain. With subtractive technology, you will be able to build only the external surface. Whereas with present additive technology, you will be able to build the complex internal structure as well as external structure. And that makes a big difference. So what is this rapid prototyping? When we talk about rapid prototyping, it is a formalized term for additive manufacturing. Basically, when you are planning to prepare a first model of any particular design. But when we go ahead with manufacturing, it is better to use a terminology of additive manufacturing or 3D printing rather than using rapid prototyping. So what are the steps involved in additive manufacturing or rapid prototyping? The first step is developing a CAD model. This CAD model can be generated using a reverse engineering technology with the help of scanners or camera. In fact, when we talk about medical field, there are various devices which includes computed tomographic image, which includes ultrasound, which includes MRI. These images help us to generate a CAD model. Whatever be the source of data, the next step involves conversion of this data to STL file, which is abbreviated for stereolithography. STL file is a surface information which includes triangle vertices and surface normal vectors. This STL file does not have any information regarding unit, color, material, or any other information. As a result of this, in recent time, there is an adaptation of newer format which is called as AML or AMF file and VRML files, which has a better data information of color, vector, size, and surface information. Sometimes it does happen, the data obtained from the STL file is slightly corrupt. There are few softwares. One of the most popular software is Magic software from Materialized company, which helps to repair such corrupted data. The next step involves transfer of this STL file to a additive manufacturing machine, where the complete information is transferred, and that particular transfer is called as G-code. At this point of time, we can verify the data, whatever is obtained, verify the structure, whatever you are going to print. In fact, from this step onwards, there is a person-to-person variability when it's all about skill from here. What I mean to say is, for the same data, same machine, two different person will be able to produce a better, maybe like someone will be able to produce a better quality product. This because the skill what he has developed over here. Next step, which involves the giving command to a AM machine. When we say about giving command, it includes the complete information regarding the time, layer thickness, the material which is being to used, the quantity of material which is being to used, and so many other things. So basically what we are doing is we are preparing the machine to go ahead with a printing step. Once you are done with the machine setup and given command, the next step is manufacturing. Basically at this point of time we need not do much, but yeah, we need to observe regarding other factor. Say for example, if there is a material, sufficient amount of material is there or not. If material got exhausted, we need to refill it. We need to also see a continuous electricity supply, and this process continues till the complete model is printed. Once the model is printed, the next step involves removal of the model and post-processing. When I'm saying post-processing, it means the material or the model what we have obtained from the 3D printing, most of the time it is not complete. Whether it is a surface accuracy, whether it is a curing, or whether it is like the complete strength what it is supposed to achieve. So post-processing is a complete complex step which is different for different types of material, and each material has to undergo for those processing steps to achieve its complete property in physical form. Once the post-processing is complete, then your model is ready. All those technology which develops a three-dimensional object in a layer by layer way are categorized into 3D printing technology. There are various types of 3D printing technology which is available in market, producing a range of material. All those technology is subdivided into three different categories. First is a liquid polymer system, second is discrete particle system, and third is molten material system. One of the most popular technique of 3D printing is wet photopolymerization. In wet photopolymerization technique, we use a light curable resin as a primary source of printing material. And this primary source of printing material is basically procured by various radiation sources. These various radiation sources can be a gamma rays, UV rays, visible light, and X-rays. This radiation sources falls on this light curable resin, and as this resin layer cures, the platform dips down by a layer which is predetermined during the CAD designing. As this layer by layer forms, it results into a 3D printed object. This technology is not a new technology. In fact, the first technology which was developed in 1984 by Charles Hull was the same. And since then, we see a lot many modification and development in this technology, whether it is a curing technique or whether it is about the source of radiation. Normally, when we talk about this technology, the source of radiation or curing technique is broadly categorized into three headings. First is a point-wise curing, where a single source cures the resin in a point-wise. Second is mask curing or mask system, where a digital micrometer device is used to cure the complete layer. Advantages: it gives a faster printing. And third one is two-source printing or two-photon printing. In this, a two different source of photon is used to cure the resin. The advantages: better printing speed and much better finish and superior quality. Another popular technology which is used nowadays is powder bed fusion. In this particular technique, one or more thermal sources are used to induce fusion between the particles. One of the most common thermal source is laser. When laser is used for inducing fusion between the powder polymer particle, it is called as polymer laser sintering or PLS, and when this laser is used for metal, it is called as metal laser sintering. Normally, this sintering process takes place inside an enclosed chamber filled with nitrogen gas. This is to prevent oxidation and degradation of metal particle. This technology, even though very commonly used, but it gives a very successful outcome. Chemical induced sintering and electron beam melting are other type of powder bed fusion. In chemical induced sintering, a thermal activated chemical reaction takes place between the different particles which are present in the platform or powder and atmospheric gases. Whereas in electron beam melting, rather than using a laser, an electron beam is used to melt the surface of powder particle, and which helps in sintering process. When we compare the sintering process which is done by electron beam and a laser, we get a higher accuracy in laser, but electron beam has an advantage of greater speed of production. Another very popular system of 3D printing is called as EBS or extrusion based system. I think many of you are already familiar with this system, and in fact I think you have already seen this system. In this, you can compare this system with icing over the cake, where a material is forcefully ejected out through a nozzle, and when it is ejected out, it is deposited layer by layer. In this particular system, you need to have some kind of scanner which determines the starting and ending point. And once the layer is deposited, either the printed part goes down or the extruder machines is indexed upward in the predetermined layer thickness. Yeah, here it is also important for me to tell you is, like, whenever we are printing any material, obviously it is in various shape, size and form, and it is not necessary it will be on the hierarchy system where the bottom is broad and or the tip is narrow. But many a times you do encounter a model where there is a lot of undercut. How about supporting of that undercut? As we know that this particular material which is like hanging or unsupported, the material when it is deposited, it is soft in consistency and there are very high chances it will distort. So what is important for us is we need to have some kind of support over here. This is called as supporting material. Normally when we talk about supporting material, there are two different types of supporting technique or material. One which is called as natural support. You must have, we have already discussed natural support in PBS system or powder bed fusion system, where the printed particle is surrounded all around by a similar particle which gives support as it acts as a natural support. Whereas in other printing system, like in extrusion based system, you need to have a secondary support. This secondary support can be of two types. One is similar particle or similar material support, like whatever material you are using to print the 3D object, same material is used to give support. And there is also called as secondary support system. In secondary support system, some other material or some other material is used to give support, and that material is selected on the basis of ease of removability. Like once the 3D model is printed, such materials are used which can be very easily cleaned and removed during the post-processing system. One of the most common material which is used for the EBS system is ABS+, which is acrylonitrile butadiene styrene reinforced with polycarbonate. One of the most important implementation of EBS technology in the field of medicine is bioextrusion. Bioextrusion is a technique of creating framework which is either biocompatible or biodegradable. This framework is commonly referred as scaffold. This scaffold provides a nide for the living cell to generate and propagate in a form of tissue, very much implemented in the field of tissue engineering. One of the commonly used material or polymer is PCl, polycaprolactone. In fact, we already see few of the technology which is available in market, such as osteopore, 3D bioplotter by Eversonic. Osteopore is like successfully produced bone graft. Either it can be in the form of osteoplugs, which is used for placement during the extraction socket. It is also used for the patient specific implant, which is commonly used for fabrication of orbital floor implant and few other places. Similarly, when we talk about a 3D plotter system, 3D bioplotter system by Eversonic, this provides a scaffold which is very much implemented in the field of tissue engineering, and in fact scientists has almost reached to a success level of generating successful various tissues, whether it is a bone, whether it is heart, whether it is few other important body parts such as ear or nasal cartilage. But what we see is a success story as a result of 3D printing technology. Similarly, FDM technology has reached from very complex structure to a grassroots level, where the printing of rocket parts to our kitchen goods, kitchen dishes are being printed with this technology. In fact, it is very interesting to see part of FDM which is called as Fab Home, where a lot many small day-to-day stuffs are being printed using this particular technology. Another commercially well-established 3D printing technology is called as material jetting. In this particular technique, it's like quite similar to inkjet printer, where layer by layer is printed, giving rise to a three-dimensional object. In this particular technique, a molten form of either wax, metal or ceramic is sprinkled over a very small localized area in a very controlled fashion, giving rise to a three-dimensional object. This technique is very much useful for concept modeling and investment casting. In fact, this technique is very well established in the field of jewelry investment pattern making. Another 3D printing technology which is quite similar to material jetting technology is called as binder jetting. In case of binder jetting, through the nozzle, rather than the complete print material, only part of the print material or some kind of binding material is ejected out. And this part print material or binding material, it is spread over the rest of the material which is there in the platform, leading to the layer by layer formation, which leads to a three-dimensional structure. But important thing is that whatever three-dimensional structure which is printed over this point of time does not have actual physical and chemical property. So this is like partially prepared or partially ready, and this needs to be processed further to get its final strength, which is like quite similar to post-processing technique. Other than all this popular technique, there are a few other techniques like sheath lamination process, which is like a combination of subtractive and additive manufacturing technology, in which all the different sheets are being fused to each other layer by layer using our additive technology, and then with the help of milling tool, that is again chopped out. It is like how cake is built in multiple tier, and then later the cake is sliced to a particular shape and size. So that's again a technique. It is very well used in the industrial purpose, but it has a limited use in medical field. Then we have something called as direct energy technique, and then there is one more well accepted terminology called as direct digital manufacturing. When we say direct digital manufacturing, it is like all those 3D printing technique which was previously used for rapid prototyping, but now it is being commercially implemented. Like those technology is used for the production at commercial level. So that is called as direct digital manufacturing. In case of medical field, we see that few technique which is used for large scale production. A beautiful example is of aligner. Then the hearing aid what we use is also produced at very large scale or commercial level, and then there are few other technology. Now coming to the topic of 3D printing has numerous applications and gained much interest in medical world. In present scenario, the 3D printing has revolutionized the medical system and is being implemented in various aspects of medical treatment, starting from diagnostic aid, surgical planning, providing a complex prosthesis to the patient, manufacturing of medically related product, especially the pharma industry, and most interestingly in the field of tissue engineering. Let us discuss my experience with this technology to provide a better quality treatment to the patient. Almost 11 years back, this gypsum based 3D model was generated using a material jetting technique. We found that it was easy to communicate with the patient, and it also provided a better level of understanding regarding the pathology and line of treatment to the patient. With this 3D cardiac model, a surgeon can have a beautiful understanding about external as well as internal anatomy. Sometimes 3D model act as an important tool to determine the anatomical boundaries post resection, as we did with this case fabricated a stand for the orbital margin determination post resection. One of the most common difficulty we face while surgery is approximation of vital structure. As in this case, when I decided to plan a maxillofacial implant in the supraorbital and lateral orbital margin, with the help of imaging aid and also with the help of planning software, I was not confident enough to place an implant. But mock surgery on a 3D model gave me a much learning orientation, but also a well needed confidence. And with the combination of skill and technology, I was able to place an implant in an accurate position, avoiding any kind of complication. Surgical stent printed with 3D technology act as an important tool which increases the accuracy and also reduces the surgical time. In my day-to-day implant dentistry practice, the 3D software based planning and 3D printed surgical guide gives me an accurate and successful surgical as well as prosthetic outcome. Similar concept of guided surgery with 3D printed surgical stent is also implemented in implant supported maxillofacial prosthesis. Jaw reconstruction using a free fibula graft needs a high skill and it's a time taking procedure. But when the same process is carried out using a guided software and a 3D printed model, it increases the accuracy, increases the success rate, and reduces the surgical time. During my training period, I learned that rehabilitation of maxillary defect is possible with 3D printed onco implant system, and also a 3D printed model can be an important tool in our orthodontic surgery planning. I have started using digital dentistry in my practice. Printed models and printed temporary crowns gives a satisfactory outcome. 3D printed complete denture prosthesis has already replaced the cumbersome laboratory technique associated with conventional complete denture prosthesis, giving rise to more accurate and higher aesthetic prosthesis. We all have witnessed the success story of vacuum-formed orthodontic aligner printed over the 3D model, which is generated with the help of software and printing technology. 3D printed implant is time-saving, more accurate, and prevent donor site morbidity. The pre-contoured reconstruction plate gives a very superior aesthetics. And for me, the fabrication of customized restructure was not possible in this particular case without a 3D printed model. This was an interesting case of large cranial defect where cranioplasty was not possible without use of 3D printing technology. Use of this technology has proven to give a long-term successful surgical and aesthetic outcome. I fabricated a cranioplasty implant for this particular case 11 years back, and still it is successful. This 2.5-year-old kid with maxillary tumor extending till the orbital floor, 3D model gave a better orientation about the lesion, and surgeon was able to do mock surgery in the model. It was much more comfortable for me to go ahead with providing surgical and prosthetic assistance to the surgeon. In this post-trauma bony malunion case, 3D printing was an important tool. I was able to provide a patient-specific solution to the operating surgeon, and overall, a teamwork is life-changing for the patient. This case is close to my heart, where an army man has cranial gunshot through and through injury, and the reconstruction was done for him using a patient-specific solution, providing him a patient-specific implant and an ocular prosthesis. This is a strong picture which is a source of motivation for many of us. It keeps us motivating to work in the field of maxillofacial prosthesis. Another important implication of 3D printing technology is in the field of medical manufacturing, especially the pharma industry. In zip dose technology, highly dispersible aerated tablets are formed layer by layer with the use of 3D printing technology. Another important aspect of implementation of 3D printing technology in tissue engineering is about biofabrication. When we say biofabrication, it is a multidisciplinary or interdisciplinary approach of biology, material science, and engineering, which help us to produce a biomimic, bioprototype, and bioimplementation, leading to a cutting-edge technology. Here, when we talk about biofabrication, rather than a 3D printing technology, we should start using the word 4D technology. So what is the difference between 3D printing technology and 4D printing technology? 4D printing technology is ability of a 3D printing object to transform itself under the presence of stimuli or with time. The similar concept we are implementing in dentistry in the form of guided bone regeneration, where a 3D printed meshwork is adapted in a bone defect site, which gives a scaffold for the augmenting material. Whatever we are implementing over here is at very grassroots level, but it is very interesting and satisfying to see the implementation of this concept to a life-changing scenario. This is the first case done in Europe for the reconstruction of jaw with the use of 3D printing technology and tissue engineering. Future is going to show a lot many perspective. Whatever I spoke today is just a tip of iceberg, and there are a lot many things which we can explore. What I can say at last is it's all about quality of life. We have to restore those millions and millions of spine which have been lost. Thank you very much for your patient hearing.